Hey guys, in this video I'm going to talk about understating the graphs of quadratic functions. So I'm going to go into just some more gritty details kind of about them. And if you've never watched my videos before, I highly recommend you pause and try the examples when you're prompted. And I always have free guided notes available. I highly recommend them for this particular video just because I have graph paper already on there for you, so they're really nicely laid out for this lesson. Okay, so let's start by just reviewing what is the form of a quadratic function. So in general, when we think of quadratic functions, we think of things that are in this form. So this should be something that you are already familiar with if you're watching this video. And the only thing about it is a, b, and c are real numbers and a can't be 0. And one other thing you should be able to do before we start this lesson, you should already know how to graph things that look like this. I've discussed this in great detail in another video, so if you don't know how to do this at all, I highly recommend checking out the description and watching one of those videos just to get you up to speed. So if you feel comfortable with this, go ahead and graph these two. Hit play when you're ready. Okay, so we know that this is going to move 2 to the left and 3 down. So I'm going to go ahead and go 2 to the left and 3 down. And I have discussed in great detail kind of how to graph this all out. So in my other video, I've talked about going out 1 and up 1 in each direction. That's kind of the general form of how you get to a parabola. So let's see, I'm going to go like this and pretend that looks nice and connected. And so that would be how that one graphs. And then for this other one, so now this one's going to go 3 to the right and 1 up. And so let's see, I go 3 to the right, 1 up. So here's where my vertex will be. Then I go out 1 and down 1 in each direction. And so there we go. It's going to look like that. And it's down right because there's a negative right here. So these should be things you're already comfortable with before you start this video. If this just does not ring a bell to you at all, highly recommend you just watch the other one. I give you lots of tips and tricks on how you can kind of quickly graph these types of things. So without further ado, let's get into this lesson. So what I'm going to do now is I'm actually going to put a number in front of this x squared, and I want to show you just how we kind of interpret this. So first, let me begin by just drawing x squared in white. Okay, so here's just the graph of general x squared, and I want to just compare what happens when I have 3x squared. So what this 3 is basically doing is it's creating a stretch factor on the y's. So you'll still start in the same place of 0, 0, but basically what this number in front will do is it will kind of dictate how your next points are going to move out from there. So this is now just taking every single point now and stretching it by 3. So what that would mean from kind of the standpoint of how we think of graphing these things, normally with a parabola I go out 1 and up 1 in each direction. But now instead, I'm still going to go out 1. That doesn't change. It's a stretch factor not on the x's, but on the y's. So I still go out the same amount. But now instead of going up 1, how many do you think I go up? I go up 1, 2, 3. So let me graph this in this pink color just so you can see it. So I go out 1, and now I'm going to just apply this stretch factor to my y's. And so now this is what it looks like. So it's a much narrower graph. So that's how you can kind of think of this number that's in front. It's really stretching what's happening to the y's. Sometimes people say, oh, it's a slope, and it's not a slope. Don't think of it as a slope. Slopes only work for lines. This is not a line, this is a parabola. So think of it more as a stretch factor for your y's. All right, so let's take a look at this other one. Just what happens now when I've got the whole shebang here. So you're still going to approach this like you would any other graph. So first things first, I'd interpret this as this moves to the right 2 and up 1. So I'm going to put that for my vertex. So right 2, up 1. And in this case, this is going to go down. But now I'm still going to go out 1 in each direction. But how far should I go down? Now I'm going to go down half of a coordinate. So normally I went out 1 and down 1. Now I'm going to go out 1 and down half. And you'll see kind of you have to approximate this, so just do your best. And you can already see kind of how that impacts the graph. So now having this -1/2, this actually made a much wider parabola. So that's kind of how we can think of this. Okay, So now that we get that, I want you to try graphing these two just to make sure you've got the concept down. So go ahead and graph those, hit play when you're ready to see the solution. Okay, so for this one, so I'm going to start by going to the left 1 and up 3. So here's my first point. And now I need to go out 1 and down 2 in each direction. This is telling me to go down 2. So I go out 1 and down 2 in each direction, and so that helps me pick up my stretch factor. Okay, let's do the other one. So now I'm going to go to the right 2 and down 2, and now I'm going to go out 1 and then up 1/3. So that's going to look like barely anything on the graph that I have drawn, but it's going to be a really wide parabola like this. So it's all the same stuff from before that I've talked about in my other videos. I just now have this stretch factor that kind of changes things. Okay, so now I can tell you guys that there's actually another form of the parabola. So I opened this up by telling you about this is the form of a quadratic function, but this is not the only form. In fact, if you think about it, we've been graphing parabolas off of everything that doesn't look like this, right? So the other form of a parabola, we write it like this. We have f of x equals a times x minus h squared plus k. This is my other form. Now, there's a few things about this that I want to note. So when I have a parabola that's in this form, so first and foremost, you know the vertex just by looking at this. It's the first point that you keep picking up, right? So when you look at this and you say, oh, it's moving this many to the right and this many up or left or down or whatever, you're actually choosing out the vertex. So HK is the vertex, and it's also telling you kind of that shifting factor that you've been using. So now we just have to translate this to the language of it's the vertex, so it's the highest or lowest point of the parabola. Now, from there, I can also determine the axis of symmetry. The axis of symmetry, in case you've forgotten what it is, so here's my parabola, here's my vertex. The axis of symmetry is the line that, it's an invisible line that divides the parabola perfectly in half. And the vertex, maybe I should just state that, the vertex is either the highest or lowest point on a parabola. So this axis of symmetry, this would be the invisible line that you could come up with to separate the graph in halves. And then the last thing I want to mention about this form is now something with that a. So if this a is a positive number, does it open up or down? Well, we've already been working with this. If the a is a positive number, then the parabola is going to open upwards. And we've already seen when this a is negative, it opens downwards. And also this a now will determine kind of the stretch factor of our parabola. So we get a lot of information, actually this form of an equation. It's really, really handy for graphing and if we have to do anything with the parabola. So what I want to do now is I really want to get used to using this equation. So what we're going to do for all of the exercises that I have left here, we're going to find and state the vertex, the axis of symmetry, then we're also going to find the x and y intercepts, and then we're going to graph the function. So I'm going to walk you through a couple of these. So let's start with this first one. So I've got f of x equals x minus 3 squared minus 4. So I want to find the vertex of this. So you're probably thinking to yourself, if you were to graph this, you would move right 3 and down 4. So now you just have to write that in terms of a vertex. Right 3 would bring you to 3 and then negative 4. There's my vertex. Now, my axis of symmetry, it's always just whatever the x part of that coordinate is. You do want to write this actually as an equation. If you just write 3 is meaningless, right? You have to actually state the equation of the line. X equals 3 is a line, 3 is nothing. Okay, so now let's talk about x-intercepts. So how do you find x-intercepts? X-intercepts in general are found by setting the equation equal to 0. So I'll just note that. You want to set the equation equal to 0. So I'm going to have x minus 3 squared minus 4 equals 0. So now that I've actually written this down, you have to think about what you know about quadratics. And this actually looks very similar to how you would use the square root property. If you have no idea what the square root property is, I will drop a link in the description with a video to that, because that would be very handy to kind of know. I'll also drop just a really quick explanation video where I go through all the different ways you can solve quadratics, so I'll drop that in the description as well. Okay, so I want to use the square root property to solve this. So what I have to do is I have to isolate this thing that's being squared. So to do that, the first thing I've got to do is I've just got to add 4 to each side. So now I've got x minus 3 squared equals 4. And now I'm going to take the square root of each side. But part of being the square root property is that I take plus or minus of this square root. So now I'm going to have x minus 3 equals, this is going to come out to plus or minus 2. And now I've got to break this into two cases. So I have x minus 3 equals 2, and I have x minus 3 equals negative 2. So I have to solve these. So if I add 3 to each side for this equation, I get x equals 5. And if I add 3 to each side in this equation, I get x equals 1. And so these are my two x-intercepts. So I have to actually state these as points though. So they're 2 points. And I know the x-coordinate for each point. The first x-coordinate is 5, 0. Remember, the 0 comes from because we set the equation equal to 0. And then the second intercept will be 1, 0. So those are my two x-intercepts. So that's a little bit more work. The y-intercept, thankfully, is a bit easier to figure out. You just plug in 0 for x. So I'll just maybe note that again. So I just have to really evaluate what is f of 0. And just be careful because you have to use the order of operations here. So sometimes people are like, oh, it's so simple. And then they forget the order of operations and then they make a mistake. So, okay, so I've got to just be careful. So this is negative 3 squared minus 4. So negative 3 in parentheses, when I square it, this becomes positive. So this becomes really just 9 minus 4. So this equals 5. And then you want to state it as a point. So this would be the point 0, 5. So there are your x and y intercepts. Okay, so now I want to graph this, and so let's see, we already said that I'm going to go 3 and down 4, so there's where my graph starts. And then I'm going to have, why don't I go ahead actually and just reflect my x and y intercepts in this case. So I have 1, 0, and then 1, 2, 3, 4, 5. There's my other x-intercept, and then I also said that 0, 5 was my y-intercept, so 1, 2, 3, 4, 5. So I marked a couple of points here just to make this a little bit more realistic. So if you have them and if they're easy to graph, that would be kind of what you do. And so now you can kind of see how the parabola looks. And all the points make sense when we graph them, right? For instance, if I had a point that ended up somewhere out here, and then the rest of these were this way, that would tell me I probably made a mistake somewhere. So this is kind of the idea of what we're going to be doing, and I have several more examples of this to kind of walk you through. And hey, while you're here, if you're finding this information helpful, maybe you could consider liking this video or subscribing to this channel or leaving a comment. I'm trying to build this channel so I can give free math help to everybody. So I really appreciate the support. Okay, so let's do another one of these together just to kind of walk you through it, and then I'll have a couple that you can try. So first and foremost, maybe you want to pause the video just to think about these first two parts. What's the vertex and axis of symmetry? Hit play when you're ready. So don't let that -2 throw you off. It's still all the same stuff. So in this case, my vertex is going to be 3, 8. And then my axis of symmetry, so it's still just that x coordinates. That's the first part. Okay, so now let's walk through the x-intercepts together. So now what I've got to do is I've got to set this whole thing equal to 0. So this becomes -2 times x minus 3 squared plus 8. I'm going to set that equal to 0. Now, notice the thing that's being squared. This is a little bit trickier in this case. Here's the part that's squared. This -2 is not squared, so ultimately our goal is to kind of get just this piece isolated. So what I want to do first is I want to subtract off the 8. Use the white color here. Subtract off the 8. So I get -2 times x minus 3 squared equals -8. Now to finish isolating this squared part, what I want to do is I want to divide both sides by -2. And so now I've got x minus 3 squared equals +4. And now I'm good to go, right? So now I can just go ahead and use the square root property, bada bing, bada boom. So I'm going to do this. This becomes x minus 3 equals plus or minus 2, and now I can break it off into my two cases. So I'm going to have x minus 3 equals 2. So if I add 3 to each side, I think we actually get the exact same answers as last time. Oh, that's funny. So I get x equals 5, and then the other one I have x minus 3 equals negative 2. So I add 3 to each side, and I get x equals 1. So my x-intercepts are actually the exact same. Oh, that's so funny. Okay, so 1, 0, 5, 0, those would be my x-intercepts in this case. And then your y-intercepts, if you just want to plug in 0 just to make sure you can kind of get through this part, hit play when you're ready. So I'm going to plug in 0 into this. And so for following the order of operations, you just want to be careful here. So let's see, I get negative 2 times negative 3 squared plus 8. So this is going to be negative 2 times 9 plus 8. And so then this is going to be negative 18 plus 8. So then this is going to be negative 10. So my y-intercept is going to be 0, negative 10 in this case. Okay, so now let's graph this guy. This time I'm not going to be worried about getting the intercepts just because I don't have enough room on the graph, but if you want to try to estimate it, that's totally fine. So remember we said we're going to move 3 to the right and then 1, 2, 3, 4, oops. 3, 4, 5, 6, oh, I need one more tick mark. Actually, I guess I'll go by 2s in this case. So let's do this 2, 4, 6, 8, and then this will also be 2, 4, 6, 8. So each tick mark will stand for 2. Okay, so I want to start this at positive 3, comma 8. So I'm going to start it here. And then I'm going to go out 1 and down 2 in each direction. So I just have to be careful now with my scale. So I go out 1 and then down 2, out 1 and down 2. And so here would kind of be my graph. Actually, let me see if I can do a little better. This is going to go somewhere like this. Yeah, and now you can actually see just from how the way I've got this scaled, it also looks like it goes through the right y-intercept and x-intercepts. So here's kind of the idea behind this. Okay, so if you'd like to see more examples, so this is kind of the gist of it. If you want to see more examples, I have 2 more here. So you're welcome to give them a try. They do end up with kind of, little plot twists in them. So feel free to try these. Pause, hit play when you're ready. Okay, so for this next one, so my vertex is negative 2, negative 3, and my axis of symmetry is negative 2. Okay, so now for my x-intercepts. So I need to set this whole thing equal to 0. And so once again, I have to work on getting this squared part by itself. So I know there's that fraction in front, but I'm just going to worry about that when I get to it. So now I have 1/4 times this squared thing. So how would I get rid of the 1/4? Well, you'll just multiply each side by 4. And now I get x plus 2 squared equals 12. Now here's a little bit of a plot twist. In this case, when you take the square root of each side, this is not going to be a perfect square. And sometimes that happens, and it's not the end of the world. So if I take the square root of each side, so the only thing I can really do is simplify this square root. So this will become x plus 2 equals plus or minus 2 times the square root of 3. So once again, I'm assuming that you know how to simplify square roots. If you need a refresher on that, I'll drop a link to that as well in the comments. And so then to really solve this, so I would just subtract 2. So I would get x equals negative 2 plus or minus 2 times the square root of 3. And there's nothing else you can really do with this, right? So I can break this up into 2 different coordinates like this. So my 2 different x-intercepts. But not square root of 0, square root of 3, my bad. So those would be my 2 x-intercepts. They're going to be some weird decimal. That's okay. Sometimes that happens. Not everything's going to work out as whole numbers. Now for my y-intercept, I'm going to go ahead and plug in the 0. So I get 0 plus 2 squared minus 3. So then this will become 1/4 times 2 squared minus 3. Let's see, this is f of 0. So my f of 0 is now going to be 1/4 times 4 minus 3. and that becomes 1 minus 3, and so then that equals -2. So then my y-intercept in this case is going to be 0, -2. And now if I want to graph this, so let's see, we said we go left 2, down 3, and then I'm going to go out 1 in each direction, and I'm going to go up just 1/4, so this is going to be a pretty wide parabola in this case. So that's kind of an approximation of it. So that would be the idea. Okay, so moving on to this last one. So my vertex in this case, this is going to be 1, 3. My axis of symmetry is x equals 1. So for my x-intercepts, so let's see, I have -1/3 x minus 1 squared plus 3 equals 0. So first I'll subtract off the 3's, so I get -1/3 x minus 1 squared equals -3. Now multiply each side by -3, so I get x minus 1 squared equals 9. Take the square root of each side. So I get x minus 1 equals plus or minus 3. So now I can break this into my two cases. So this will be x minus 1 equals +3. So then I'll add the 1 to each side. So I get x equals 4. And then for my other one, I have x minus 1 equals -3. I'll add 1 to each side and I get x equals -2. So my two x-intercepts in this case are 4, 0 and -2, 0. And now for my y-intercept, so I'm going to plug in 0 into this. So this becomes -1/3 0 minus 1 squared plus 3. So let's just kind of follow through on this. So I have f of 0 equals -1/3 times -1 squared plus 3. So this will become -1/3 times 1 plus 3. And so now I'm going to have to deal with the fraction, not the end of the world. So what I need to do is I need to convert 3 into a fraction that's over 3. So 3, remember, 3 is over an invisible 1. So then I need to multiply the top and bottom by 3 over 3. I'm multiplying it by 3 over 3 so that I get this denominator of 3 that I want. So this will be f of 0 equals -1/3 plus now 9 over 3. So ultimately my f of 0 will equal +8 over 3. +8. So then my y-intercept is 0 and 8/3. And now for the last part of this. So now I'm just going to graph it. So I go over to 1, I go up to 3, and then I'm going to go out 1 and down 1/3 in each direction. And I'm just going to try to approximate this as best I can. So it's going to be something that looks like that. Okay, so that covers this entire video. So thanks a lot for watching. I have a lot of other videos on intermediate algebra, and currently I have a whole series on calculus. So hopefully I'll catch you guys in another video. Thanks for watching.